On the last video, we had gotten our interface up. So we had our IoT interface, and we had just finished making our first wireless interface. So for further testing in this video, I'm actually going to enable this. And what I'm going to do is I'm going to use my phone. I'm going to connect it to this interface, and basically I'm going to use that connection to gauge how successful we are in making it back to the gateway. Because if you remember, I am using a pfSense gateway and a UniFi switch. So our VLAN is going to have to go all the way to the gateway. So let's see, I'm connecting my phone right now. Let's see if it pops up. There's a very good chance that in this current state we're going to have to do a lot. Okay, so we are connected. This is my phone. Let's see. Does appear that we have internet access. So let's make sure that we can reach our gateway, which is 192.168.1.1. All right. So we can't reach our gateway, but let's check out our DHCP server. Okay, so right off the bat, just coming from where we started, we can reach our DHCP server. So if you remember, that's the IPv4 gateway that we set in our IoT interfaces. This is actually our DHCP server for VLAN 20. So we can reach this, that's fine, but we actually can't reach our gateway. So we have some weird stuff happening right now. And we're going to have to figure out what's going on. So first thing that I'm going to do, I know how much my firewall does not like IPv6. I have some rules against using it. I'm going to make sure that ICMP redirects are on. I'm also going to make sure that IGMP snooping is on. Going to accept local. Alright, that looks good. I'm going to save and apply this. I am also going to do the same thing on this interface. Make sure IPv6 is turned off. Going to enable IGMP snooping. So what IGMP snooping does is when you're using a bridge is, it's connecting everything together. So let's say you have four ports on one side and 4 ports on the other side. All the traffic coming in and out of those ports is just going to be flooded. And what IGMP snooping does is it helps you reduce the amount of flooding that each port gets. Because not all the time is every port going to need to be flooded. Sometimes you may only want like 1 or 2 ports flooded. Or, maybe you don't want your Wi-Fi flooded. So that's what IGMP snooping is going to be for. We're also going to make sure LAN 1 has IPv6 turned off. Bridge specific, we want to turn this on. That looks good. Enable local. All right. Let's see if we have any improvement in our gateway connection status. Okay, still 100% packet loss. That is not ideal. IPv6 is undefined. Oh, interesting. So occasionally I'm not sure if this is a bug, but my BR LAN port is claiming to only be bridging 3 ports right now, as you can see in that diagram. So I'm going to take this LAN port 1, out of my VLANs bridge and see if I can get the connection to my gateway with it out. Okay, so now we have 4 ports on our LAN bridge again. Let's give another ping to our gateway. Okay, so now with LAN port 1 out of our VLAN bridge, we have a solid connection to our gateway. So I'm going to try adding it back in and see if it stays. And once I add it back in, I'm also going to have to re-tag the VLAN IDs. So I'm going to have this one tagged, and this one tagged. Make sure all these are good. Those look good. Save and apply. Alright. So now I have my 4 interfaces back. Let's check my phone and make sure that it still has connectivity. Alright, we are still connected. Let's make sure it works. Alright. So, despite being connected, I am not getting any internet right now on my phone. So, if we go to diagnostics, see if we can ping openwrt.org. So we can ping openwrt.org, but it doesn't look like we can use our .20 VLAN now. Let's try the DHCP server. No luck. Okay. I'm going to try restarting this interface. So we have our 4 ports back on our LAN. Our LAN is connected, but now our IoT interface is not connected and we seem to be having issues. What are these unsaved changes? Oh, I never applied those. Oh my gosh, I'm a goof. I think that might have been the reason why our IoT interface wasn't working. Sometimes it's hard to keep up with all of the changes. Alright, I'm waiting for my phone to repopulate this network. Okay, so my phone is reconnected, and it also has internet. So we're going to go back to our diagnostics. We're going to ping the gateway, make sure everything's good. I'm also going to ping the DHCP server, which should also be good because my phone was given an IP address. Okay, they're both good now. Now that we know that our gateway is connected and it's properly distributing IP addresses to our VLANs, what we can do is we can go in and make the rest of our interfaces. And then we can start setting up firewall zones. So next interface is going to be STV. It's going to be using VLAN 60. And this is going to also have a .1 as the gateway, because this is .60.1 is going to be our DHCP server. Okay, that looks good. Save and apply. Now we are going to create our Wi-Fi interface. So our Wi-Fi interface is also going to be static. It's going to be using our .30 interface with a .30 subnet. Okay. So in order to stay consistent with the diagram that I initially made, I am going to go into my wireless networks and I'm going to start adding my networks. I'm going to add my 5G network first, just to show you guys. So my 5G network is going to be using the Wi-Fi interface, and we'll have the SSID have something to do with 5G, just so people know what they're getting themselves into. I'm also going to make this WPA3. Okay. And I guess a quick note while we're here. So if for whatever reason on your IoT network you're having issues pairing your IoT devices, a fix that I have found with some of the less compatible radios is to disable WMM mode, or Wi-Fi multimedia mode. Unfortunately, this will limit your devices to 802.11 rate, or basically everything's going to be much slower. But despite your network being much slower, your IoT devices are going to be a lot happier. And so in our implementation, we have our own IoT network. So this Wi-Fi network being really slow is not going to affect our 5G network at all. So I'm going to enable this one really quickly. And again, after I enable this, I'm going to go into my phone and I'm going to swap it over to the new network to make sure that we can get our data through, and to make sure that we can get our IP address through DHCP. Okay, so my phone has a different password set because it remembers the network. So I'm going to have to change it real quick. Alright, checking quality. Okay, awesome. So my phone's connected. It also has an IP address. I'm going to quickly look up the news. And yep, everything works. And as you can see, our rate is way faster than it was using our IoT network. So even with WMM mode turned on, your rates through your 2.4 gigahertz channel are still going to be much lower. So I'm at 780 right now. That's kind of insane. So we know our Wi-Fi interface works and we know our IoT interface works. I am going to quickly make my STV interface. Same naming configuration. Okay. It's going to be using the STV network. Also going to have this one hidden. WPA2 because my STV can't use anything else. Save and apply. Alright. Now I am going to go back into my phone and verify that this network actually functions. Connecting, it's got an IP address. Okay, so again, we have the 144 instead of the 780 for our bitrate, but our STV interface is also up and running. So in this video, we did some troubleshooting and we created our new interfaces. And we also verified that each interface is successfully retrieving DHCP addresses from our gateway. So that's going to wrap it up for this video. In the next video, we will go over how we can properly create new firewall zones for these interfaces. So I hope to see you guys in part 3.